This is number 59 from section 5.5 in Stewart. It's integration by substitution with a definite integral. And I'll do this one a little quicker. I did number 58 a second ago, and I went through a lot of detail about how you can handle the limits of integration a couple different ways. Here I'm just going to kind of go with my favorite way. So first of all, there is a substitution here needed. And the way you can kind of see that, there's a few things going on in here. We don't have a product or quotient rule for integrals, right? We have a couple different techniques. And substitution helps us deal with a chain rule, right? Like when you have a composite function. And here you see e to the 1 over x. So that 1 over x is inside of the exponential. And then you also see the divided by x squared. And what you want to, like, what could really help you to see this quickly, what can click, is if you realize that when you take a derivative of 1 over x, you're going to get a 1 over x squared, right? You got to think like, okay, if my u were 1 over x, which is like x to the negative 1, right? Then my du would be negative x to the negative 2, right? Negative x to the negative 2 dt, or sorry, dx. And which is, negative 1 over x squared dx. And so that's perfect, right? Like this u, which is inside of the exponential, the 1 over x, its derivative has this thing that is also present in the integrand. And that's how you know your substitution is working. Okay, so I'm going to put an arrow here. I'm going to say equals still. Like I'm not using the arrow just to connect them. I'm going to write something that's equal to this. I think that's kind of important to do in your work. But just since my work's taken up some space here, I wanted to be really clear about where this is coming from. Anyway, I have almost everything I need here. I have a 1 over x squared dx for my du, right? I need a negative. That's all I'm missing. I need negative 1 over x squared dx. I have positive 1 over x squared dx. So I'm going to make a negative in here. And to balance it out, like I multiplied by negative 1 inside, so I'm also going to multiply by a negative 1 on the outside. And what that lets me do now is the negative on the outside stays. And then on the inside, negative 1 over x squared dx, all of that turns into du. And then the rest is just e to the u, which is nice. This is a really easy integral to do, right? Now, as written, this is not equal to this, right? This is an indefinite integral. This is definite. Again, in that other video on number 58, I talk a lot about like all the implications of that. Here, I need to put limits here, and I can't just put 1 and 2. Those are limits on x. So I'm going to change them to limits on u. So u is 1 over x, right? If I plug 1 in for x, I get 1 over 1, which is 1. And if I plug 2 in for x, I get 1 over 2, so 1/2. So what I did is I took these limits for x, these are x values, and I plugged them in for x to convert to u values. These are the limits on u. Okay, and so now this whole thing now is equal to this as written. It's good to go. So now I just need to find the antiderivative. Antiderivative of e to the u is e to the u. One other thing. That negative, I could actually switch these limits of integration if I want, right? And make them, make them go from left to right, because right now it's going from a greater value to a lesser value. And if you want to do that, then you just multiply by negative 1, right? So that's actually convenient because I'd rather go from left to right, and I'd rather get rid of that negative. It just makes everything simpler. It makes it less likely that I'm going to have to cancel out a bunch of negatives later, or maybe I'll cancel out fewer of them. So far, so good. And I was just saying the antiderivative of e to the u is e to the u. These are limits on u. These are u values, so I don't have to go back to x. So I just go from 1/2 to 1. And now I plug in the limits of integration. E to the 1 minus e to the 1/2. I don't need any plus c because in a definite integral, you don't need it. It would just cancel itself out when you subtract. And so this is it. This is my answer. E minus e to the 1/2, or if you prefer, e minus the square root of e. That's it.